Okay, so I wanted to show you this because if you go into Math 143, which is quantitative literacy, or if you go into stats, which is Math 151 or 152, I can't remember, you're going to talk about these probabilities. And so I just wanted to go ahead and show it to you so that you would have some frame of reference. So we're going to talk about binomial probabilities, and I can solve problems using probabilities. Okay, so let's get the really boring stuff out of the way. So binomial experiments. A binomial experiment consists of n independent trials in which, one, there are only two outcomes, success or failure. That's what we're talking about. The probability of success, which we call P, is the same in every trial. And then Q represents failures. So the probability of success is P, and then the probability of failure, we use a Q, or you can think of it as being 1 minus P. So if we look at this example, we have an experiment, randomly selecting a month 30 times. A success would be January, a failure would be not January. So success, think about there's only 1 out of 12 months that are January. So failure, 1 minus 1/12 is 11 out of 12. There are 11 out of 12 months that are not January. Okay? The next one, randomly selecting a card 100 times. A success would be if it's a heart. So, remember that there are 4 suits, 1 out of 4. Alright? And then my failure would be 1 minus 1 out of 4, which is 3/4. So that's what I'm talking about when I talk about success and failures. Okay, so here is the formula. If a binomial experiment has n trials, right, and I'm going to just use some different colors, in which P is the probability of success and Q is the probability of failure, then the binomial probability that there will be exactly R successes is, and this is really crazy, so I'm going to pause the video and I'm going to color code it for you. Okay, there it is. So this is NCR, which is N combination R that we talked about already, P to the R power, and then Q to the power of N minus R. Oh, it's horrible. It's actually huge in statistics, so it's a big deal. Okay, so you pause the video, you color code it, take as much time as you need. We're going to do some examples. Alright, so we're going to look at examples with an exact number of successes. So, a coin is tossed. So a coin is tossed 25 times. That's my N. What is the probability that lands on heads? Exactly 7 times. So my success is that it lands on heads. So 1 out of 2. My failure would be it lands on tails. Still 1 out of 2. And my R, I'm talking about 7 times. Okay, so I'm going to plug all of these in. And I'm going to color code. Okay, so it should look like this. Alright, so when I type that in my calculator, I get 0.0143, or I'm going to change that to a percentage, 1.43%. Okay, so let's try the same thing with the next one. The spinner below is spun 10 times. That's my N. What is the probability that it lands on red exactly 6 times? So exactly 6 times, so my R is 6. So probability of success, I want it to land on red, which is 1 out of 3. It's actually 2 out of 6, which reduces. Which means that failure would be 2 out of 3. So now I'm going to put it in the formula. So if I put this all in the calculator, I get 0.0569. I change that to a percentage, 5.69%. All right. Okay. So I want to see if you can do these two. All right, see if you can pick out what the N, what the R, what the Q, and what the P are, and then put them in the formula. So try this in 1, 2, 3. Okay, so these are the values you should get, and now you're going to plug them into the formula. All right, and then when you plug them into your calculator, you should get this, which changes to 8.79%. And then for the next one, you should get 0.0604, and we should get 6.04%. Okay, these are not fun. I'm sorry. Let's try these two, and then, well, let me just do this. I'm going to give you the answers, and you can try if you want to. I'm just getting really bored, and I feel like I'm beating you to death with problems. So this is what you should get for these. And here's what you should get for these two. Okay, and you can ask me how I got these if you need to. So I want to get to this point, which is really, really hard. Okay, so this is when they're not exact. So it'll say at least, it'll say at most. If you look at number 9, notice it says at least. So when that happens, remember the word at least means it could be 8 times, it could also be 9 times, it could also be 10 times. So we're going to have to do this for exactly 8, exactly 9, and exactly 10, and then we're going to have to add them all together. Okay, so you know how to find the N, the R, the P, the Q. So I'm going to list out what it looks like for exactly 8, exactly 9, exactly 10. Okay, so here's how we found them in the previous problems. Exactly 8, exactly 9, exactly 10. And now I would have to add all of these together to get at least 8. And then I would change it to a percentage. Definitely not fun. Okay, so if you look at number 10, if it says at most 3 times, that's exactly 3, 2, 1, and 0. So I'm going to have to do the formula 4 different times and then add all 4 of them together. So I'm going to pause the video and I'm going to write it out, and then I'm going to show you what the numbers should be, and then we'll add them together. Okay, so just like the previous problems, this is what we would have gotten, and then when we add them all together, we get this, which is the same thing as 94.01%. Yeah. Alright. These are so time-consuming and boring. I'm just going to give you the answers, and then if you want to try them, you can, and if you try them and you need extra help, then send me a message and I'll help you as much as I can. Alright, so I'm pretty sure there's a problem for you to do. Let me know if you have any questions about it, and I'll see you later.